sota lluna plena de plata coberta. Xali vinc amb tu sota l'abric de l'arbre verd. Abraço somnis antics sense tu. Ja no puc viure. Ballo a poc, descansa sobre pinassa. Foc, 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 creixes viu, crit salvatge. Somnis antics, peus de pinassa. Ball salvatge. Dona de plata, ets dins l'arbre verd. Gràcies.
Good evening, everyone. Welcome, and thank you very much after such a dreadful day. Things are getting better now. My name is Toni Pou. I write in several publications. I'm a scientist and a researcher. And after listening to this kind of music, it is very complicated to me to come back to the words as a way of expression. But we'll try to do it. And I'm kind of relieved because we're going to deal with that. How do we use several languages as a music and science to understand our world and also to understand how we are and who we are? Well, this song was by Carola Ortiz, and she also sang with this squared instrument, which is called the pandero cuadrado, which is a traditional instrument that many artists are trying to recover, together with Olushola at the drums. Carola plays the clarinet also. She's a musical producer, and she's going to be one of the speakers today. Thank you so much, Carola. Welcome. And congratulations for this first piece of music. Very intense and very interesting. Thank you very much. What an honor. Good evening. Well, today's session has to do with the Evolution Day that we are commemorating in Barcelona at the International EvoKE Congress. And as you can see, there are loads of institutions that made possible the Palaeontologist Foundation and many other organizations and institutions. And to commemorate this day, we are going to talk about how science helps us to understand what makes us human, but also the role of creativity in science, and what do they have in common, science and music, which at the end of the day are two different activities. Sometimes we think that they have nothing to do with each other, but we'll try to find common places. And we also have amongst us Leslea Hlusko. Welcome, Leslea. Thank you so much for being amongst us today.
Ella és paleantropòloga.
Well, she's a paleoanthropologist, a researcher in human evolution at the National Museum and Research in Human Evolution at the Museum of Burgos. And before our conversation, and you will be invited to contribute after our conversation. We'd like to know how your research is working. So Leslea, welcome. Welcome again. You have the floor.
Muchas gracias. Muchas cosas. Disculpe. Do not need to translate myself. So everything that we do, from the beautiful voice, the beautiful music, sitting here, listening to that, sitting in a room with lights, talking about art and science, moderating, breathing, everything that we are doing is only possible because our biology enables us to do this. And that biology is the result of millions and millions of years of evolution. So I am an evolutionary biologist, where musicians and artists will explore the human condition through their art, through music, through song. I study the human condition and how it came to be through science. So as a scientist, we test ideas, we test hypotheses, we collect data and try to answer questions using empirical evidence. So this flowchart shows you how science, the different forces, the different parameters that contribute into the process of testing ideas, of testing hypotheses. But tonight, I want to focus on just the one at the top, the exploration and discovery, because this is where the hypotheses come from. So the creative process really lies in exploration and discovery. I led a team that figured out evidence of human adaptation to the Arctic, an episode of adaptation that happened about 20,000 years ago. So what I want to tell you about tonight is what the creative process was that led to that discovery. And then we can share notes. So the exploration and discovery. There are 4 steps to the process of the scientific creative process. And the very first one that I learned was, or is, to say yes. Say yes, no matter how big it might feel. So in February of 2017, I gave a presentation as part of a symposium at the American Association for the Advancement of Science meeting in Boston in the United States. This was a session that was to explore the evidence of how people moved into the Americas. This is not a topic I had published on before, but it was a topic I was very interested in and wanted to bring my expertise in teeth. I wanted to bring that expertise to this question. And so I said yes. Okay, so I started with a framework that already existed, what we already knew from the science. And the first thing that we know is that about 40,000 years ago, people first moved up north into the region that is what we know now as Siberia. So people were living there 40,000 years ago. We know that about 25,000 years ago, give or take, that the Earth started going into an ice age. This was the last ice age that the Earth experienced. And with that ice age, more and more of the water became trapped in glaciers and ice sheets. And as that happened, sea level dropped by about 120 meters. And lots of land mass was exposed, and the world became very dry. At this time, people moved into this area that we now refer to as Beringia, and you can see here, because all of this nice land mass was exposed. We know also that as the last ice age started to come to an end, about 18,000 years ago, that people who had been living in Beringia started to move into the Americas. Some of them moved back into Asia, and many of them moved into North America and very rapidly into South America. So we know that. We also know that the Native Americans, the indigenous people of the Western Hemisphere, that they have a lot of biological similarities to people that are living in East Asia. And some of the evidence for this comes from teeth. So I ask you, take the tongue, your tongue, and run it against the back of the front teeth in the top of your mouth, your incisors, the teeth right in the front, and feel that very back edge. Are your incisors smooth, or is there topography? There is variation here, and we know that many of the people who live in Asia and many of the people who are indigenous to the Americas, they have topography. Scientists, we have figured out a way to measure this, of course. So we measure this on a scale of 0 to 7. And this is how we have been able to collect data to estimate that the Native Americans have a similarity to East Asians. Okay, step number 2 in the process of scientific creativity. Find time to really think. Now, I'm married, and I have a daughter, and so my life at home does not give me very much room to think. So I think really well on airplanes when I fly by myself. So I pulled together a bunch of scientific papers and read them on an airplane. And as I was turning the pages, I started noticing connections between seemingly disparate pieces of evidence. I'm going to tie them together for you now. 1. Geneticists had identified that there was really strong selection on one variant of a gene called the ectodysplasin A receptor, or EDAR. So this one variant has had an episode of very strong selection about 20,000 years ago. You can see where that variant is found in populations today by looking at the pie charts on this map, and the yellow shows the populations that have the prevalence of V370A, of this particular variant of EDAR. This is today, and geneticists said, well, maybe it's something to do with China. Maybe the selective event happened there. Now, I knew, because I studied teeth, I knew that this might not actually be the case, because a lot has happened about population movement over the years, over the last 20,000 years or more. I also knew that this gene has a very strong influence on the shape of the teeth in the front of your mouth. So we know that people who have 2 copies of that variant have shovel-shaped incisors. People who have just 1 copy, a little bit shovel-shaped. And people with no copy of that variant, they tend to have very smooth incisors on that tongue side. So this means we could look at the teeth of people who lived a long time ago and be able to interpret where this variant existed in the world. So it's like a time machine. So we used teeth to go back into the archaeological record. So I pulled in new colleagues who had thousands, 5,000 individuals. They had data on the shape of their incisors, and we plotted them on this map. And you've already seen the score key, and so you know that the hotter the color, the red or orange or yellow, the more shoveling those incisors had. And all of a sudden, this is not a story about China anymore. This is a story about the Americas. And most likely, a story about the ancestors of all of the indigenous people living in the Americas. So this took me back to Beringia and contacting colleagues and learning about paleoecology and finding out that Beringia 20,000 years ago, it was a pretty nice place to live. So it was biologically rich, and just in this one region. But people and plants and animals who came to live in this, or took refuge in this area, they were sort of trapped because there were big ice sheets to the east, and there was this big basically a desert to the west. So they were isolated for about 5 or 10,000 years. And then they were just surviving and getting by. Now, this was a nice place to live in many regards, but Beringia is also a very hard place to live. And not just because it's very cold, but it's very hard because of how far north it is. When you are that far north, you do not have much exposure of the sun on your skin. And you may be aware that you need the exposure of the sun, the ultraviolet radiation of the sun on your skin in order to make your own vitamin D. So if you don't have exposure to the sun to make vitamin D, you have to get all of your vitamin D from your diet. So people living in that area would have been very vitamin D challenged. They had to get it from their diet. So does that mean then that maybe the shovel-shaped incisors were something to do with eating a vitamin D-rich diet? Okay, step number 3. Don't limit yourself. Don't set boundaries. So don't just think about teeth if that's your expertise. Think about other things. And so my boundaries got expanded to development. So did you know that the developmental process, the embryology of your hair, of your teeth, of your sweat glands, of your mammary glands, that it's all the same? They all share the same developmental process? Well, they do. And that process is influenced by the EDAR gene. So we know quite a bit about the EDAR gene out of the medical literature, because people who have this gene where it doesn't work quite right, it doesn't express itself very much, they have ectodermal dysplasia. And people with ectodermal dysplasia have very sparse hair, they have limited number of teeth, and they tend to be very small. They have very few sweat glands, or perhaps none. And women who have ectodermal dysplasia, they won't have their breasts will not mature, and so they can't produce milk. And so we know all of this from the medical literature, but we also know quite a bit about this from biomedical research on mice, where we can insert a variant or knock out a gene so it doesn't function and see what happens to the mouse. So what we know is that for mice, when you insert the human variant that we're interested in, is that you actually increase the activity of this gene. So whereas ectodermal dysplasia is a reduction in the activity, this selection was for increased activity. So I dug through the mouse literature, and buried in the supplemental of these scientific papers was a comment about the mammary glands of these mice. And so these mammary glands, so now you're looking at a human mammary gland, a sketch, is that this human variant of EDAR, it leads to an increase in the ductal branching of the mammary glands of mice. So assuming that the same happens in humans, which for all of the other aspects of the anatomy, that's the case, so it stands to reason to hypothesize that EDAR, this variant of EDAR, is increasing the ductal branching of human mammary glands as well. Could that be related to vitamin D in the Arctic during the last ice age? Because remember, babies, they don't get enough ultraviolet radiation reaching their skin to make their own vitamin D, so they only get their vitamin D from diet. But when they're nursing, the only dietary intake they have is their mother's milk. So could this have been selection on the mammary glands to facilitate the transfer of nutrients, including vitamin D, from mother to baby? So this is what we hypothesized. And so I pulled together many colleagues from a postdoc in my lab, colleagues who had all of the dental data, the 5,000 individuals, a geneticist who was an expert on the peopling of the New World to make sure, of the Americas, to make sure that we were not being sort of going outside the evidence, someone who had a lot of knowledge about statistics, our paleoecologists working in Beringia, and archaeologists setting the stage, experts in vitamin D and ultraviolet radiation, and then also a research assistant who's very good at illustration to tie it all together for us. So we pulled it all together, which gets me now to this fourth step. And the fourth step of the creative process is perseverance. Don't give up. We submitted this paper to 2 journals who quickly rejected it, and it was the 3rd journal that ultimately published this. And in 2018, we published it in the Proceedings of the National Academy of Sciences. Pause for a moment. I know, it's just nothing compared to song. It's nothing, it's black and white, pieces of things on a paper. It means nothing. I'm sure none of you feel an emotional connection to this, unlike music. And yet I think that our process might actually be very similar to how we get to this. Now, because if we had not had this creative process to lead to this brand new hypothesis, we wouldn't have thrown out ideas, we wouldn't have new ideas about ductal branching in mammary glands having an effect on nutrient transfer. We also wouldn't have this idea that perhaps ductal branching and the ectodysplasin, this gene, might have an influence on breast cancer, because populations that have a high occurrence of this variant, they have reduced levels of certain types of breast cancers. And so these brand new ideas, they come from evolutionary biology, and they come from the creative process of evolutionary biologists. And that gets us to the very last one, the very first test of the hypothesis, which was just published last month. And with that, I'm done.
Thank you, Leslea. Moltes gràcies per aquesta presentació, que ha sigut breu, però intensa.
Thank you so much, Leslea. What an intense presentation. And it's crystal clear. It is crystal clear with the science. We can get some ideas while we fly. But these ideas, to be mature and to offer a scientific result, really need the cooperation of other individuals and the cooperation with other people. This collaboration and cooperation is a fundamental element in music, and Carola, she's aware about that. Therefore, we'd like to invite you to play another song, now together with Lucía Fumero at the keyboard and Octavio Salman at the drums. And they are going to play a song that has something to do with jazz music and it has also African colors. That's right, Carola? Yes. I'm going to merge. It's kind of a fusion. I think that this is the first fusion that I know from this Pandero Cuadrado with rhythm by Peña Parda that would be our grannies music, very, very old kind of music, mixed together with a jazz music that it's called Afro Blue, because jazz comes from blues that comes from Africa, right? So everything is connected.
Dream of a land, my
Thank you very much. Thank you for this performance. I try to write and I use words for those that read my articles, but you know, every time that I listen to this kind of music, I want to throw away my computer and to look for my guitar. Because music cannot be compared with anything else. We have the ability to capture human emotions in a straightforward manner that goes straight ahead to our brain, which is fascinating. However, let me tell you that all musicians behind this final result, which is so emotional, that comes from our stomach and there is always a logic behind. It comes from our guts, but there is something related with science always. Yes, always we have something related with science in music. Well, each and every one of us, we have our thinking code. To me, to play the pandero and to sing, it is quite challenging. They are like two linear thinking, yes. Something that have in common science and music has to do with improvisation, the art of improvising. Science and improvising, what two different words. I never listened to these two words together in a sentence, but you improvise, scientist. How does this improvising system works when you research, Leslea?
So one of the magic pieces of improvisation is finding the right people to improvise with. And so for example, maybe 5 or 6 years ago, I had found a postdoc who had an expertise and a very nice personality that we needed in the group, and then pulled graduate students together, and then everyone brought something different to the table, and I wasn't sure where we would take it, but I knew if we had these pieces together that we could figure out the next step. We could advance the scientific question. And again, it was a creative process of coming up with a hypothesis to test. And it was just magic. We would get together 2 or 3 times a week for a couple of hours and brainstorm ideas, and then everyone would run off and do their own analyses and come back or call each other at midnight. Hey, guess what? So it's the magic of having the chemistry of the different expertises and letting it go.
Yes. Now that you are talking about that, Leslea, this is the first time that we are playing together, the 4 of us.
No? Evidentment també.
And obviously, well, we have some patterns, we have the harmony, the tempo. We began with the melody and the tempo, which are the elements, I would say the basic, not basic being simple, but they are fundamental. And later on, we add different layers, different melodies, different tempos, the harmony, and the different notes and different melodies. And suddenly, the harmony began. So we began to mix and to merge the rhythm, the pace, but Lucía with the keyboard. And those codes, these rational parts, these logical parts that the majority of people do not know. But if you study a little bit of music, if you go to School of Music, you realize that it's very complex. At the end of the day, it's all mathematics. You have the relationships, you have tension, distension. There are many rules that are always present. And for us to improvise, we need to work beforehand. We are talking a lot about music, and this made me think a sentence by Frank Zappa. To speak about music, it's like dancing about architecture. So if we talk about improvising, maybe could you improvise something right now? Why not? Do you want to improvise something? Yes? Okay, go ahead.
El que passa que...
You know what happens? Well, you know, improvisation, or maybe you'll ask me later about the improvisation. Well, if you want to share something now, go ahead. We talk about the structures now, right? But improvisation, in an improvisation, we can have a structure and a non-structural improvisation. So we can follow an architecture, or we can do whatever we want, like an ocean, or get inspiration from images and from different stimuli, which are more abstract or more natural, that complete this sound. So I would set a relationship with a painting, the abstract painting, that has different elements with a logic inside, but in an abstract manner. But in improvisation, with you as a band, I think that all the stimuli come from other musicians, so you get stimulated amongst you. And suddenly you create something unique, right? It's kind of magic. Yes. Okay, let's go. I'm going to improvise. Thank you again. Thank you. Well, you created here and it only existed right now, which is a kind of magic. Well, you can listen again because they recorded that. Well, if you ask me to play it again, I don't know how to play it. Thank you so much. For this kind of improvisation, you need this kind of stimuli. You need creativity, you need also technique. You need to know how to play an instrument. When we were getting ready, when I had a previous conversation with Leslea, I was surprised because you vindicate the fact of touching. They use the verb play, and to play an instrument, but also to play a game. And Leslea, you said that scientists, they also play. Scientists also play. What do you mean by that? Let us know how scientists play or touch.
So I would just want to say that the chemistry I could feel with you all playing, it feels the same. As a scientific group, when we sit in the lab together, it's that we look at each other the same and we laugh and it's playful the same way. It's really interesting. It doesn't sound anywhere near as good, but the vibe is really similar. And so we play, especially with the creative side of the science, where you're trying to explore into new intellectual territory, is that we don't know where we're going. And so you have to just say, so for example, we had several data sets, and then we were saying, okay, well, if we analyze it this way, what happens? And it's like on the guitar, you play and see what happens. And then on the keyboard, you respond, and it's like, oh, wait, that didn't sound good, because I saw you look at each other like, oops. Oh, actually, I thought it sounded beautiful, but the look on your face. And we do the same thing, where it's like, oh, wait, that we got an interesting result, but that's not what we're trying to do. Back. And so you just keep going and coming back and going and coming back. So it's playful, but it's, yeah.
And you know, when you were describing, I mean, I actually love science as well, but when you were describing, I could feel these emotions, you know? I could feel it was very emotional for you. Yeah, so, you know, you said, you know, before previous talks like that science is only seen as rational, and for sure it's like very rational as well. But I think that you can see the passion, you know, beneath when a scientist tells you something, or even just reading an article. It's like, I'm like, wow, that's fascinating. How they just went there to that idea and then found out something, right? It was very deep as well, like questions never end, right?
So one of the things in science is that the process to get to the project, to the paper, is often really different than what the paper looks like when it is done. Is that the same for music?
Yeah, actually recordings are a bit coldish than, you know, the live music. You can never really, but you can be emotional though. You can like listen to a recording and feel emotion, but it will always feel like, for us, it will always feel like it's there, you know. It's not real, yeah. So interesting.
Leslea, you talk about the creativity processes in science when you share with us your experience. In music, creativity is a fundamental ingredient, but Carola, tell us, how does your creativity process works? Where does your songs come from? I think that they come from books that I read, dreams that I have. So it always comes from daily life things, people that you meet. I travel a lot, I get a lot of inspiration. I went to India and I met Indian musicians. And I don't know, I get inspiration from everything that awakens my curiosity. This is the spirit, scientific spirit, seeking for something. I wanted to be a scientist, I told you before. Well, seeking for something, and I don't understand that. Why I do not understand? Or maybe I had a dream. Wow, what a dream. Or a book, a character. I do have a song. Villanelle's song. He's a character by Janet Winterson that she was invited here for a speech, and all the fascinating universe of this main character, this inner universe of people, individuals, of culture, of nature. I get inspiration from nature, from trees, getting connected with nature. The daily life things, it's quite an interesting thing to me, because there are many stories of a scientist all along science history that got inspiration from daily life. We have the famous anecdote from the apples, Newton's apple. Well, he was able to write it that he saw falling the apple. Well, Newton, what a person, my God. We don't know if this was true, but he said that this, and also Einstein case, he saw a painter falling from a scaffolding with some painting, and suddenly he realized how the paint that was inside and also the painter, together they were a single unity. They were not impacted by gravity because they fall together. Instead of getting worried by the poor painter, Einstein, well, thought about a principle, which is a fundamental principle from the one he built the relativity theories. So this attentive observation of our daily life, it's quite an interesting thing, a very fertile. How do you see things, Leslea?
I love that example. Yes, daily life. And I think this is one of the reasons in science why we need diversity of who the scientists are. So for example, I've had people ask me, how did you come up with the idea of mammary glands for that being what selection was operating on? And to me, as a mother, it was the most obvious of them all, because I'm very close to an infant that was completely dependent on me for everything. And so, of course, if I'm looking at that range of anatomies that are influenced by this one gene, which is the most essential in evolution, it's babies, it's infant survival. And yet some other people, many people, so for example, one of the earlier research teams, they were aware of the effects on the mammary glands, but they thought that when they found out that it didn't have an effect on breast size, they were no longer interested in it, and it completely escaped them the whole idea of milk composition and what mammary glands are really for with babies. So I think maybe that answers to us. Everyday life, and that you need people with lots of everyday life experience, of diversity of everyday life experiences.
Actually, it's I like relation it to like genetic evolution, right? Like the stimulus, right? They say that now they've been discovering that evolution is also related to your life. Like if you have more sun or less sun, you have this food or the other food. So in that sense, I want to relate the music evolution to like genetic evolution. It's like it's like a living thing. And you were saying right before that music activates something. It's like a living thing there that is evolutioning with perdó, és que parlaré en català millor.
I'm going to speak in Catalan. I think it's much better for me. Yeah, I knew that if I speak English, suddenly I would find a black hole. Anyway, I was saying that the music has an evolution with the context and different stimuli, social impacts and culture, as well as science and genes, right?
And it begs the question, why are we so moved by music? And when did that happen? And I don't know if you wanted to talk about that now or.
Why not? Yes, you're right. What an interesting topic. Yes.
Tema super interessant.
Very interesting topic. We were mentioning before, right? How is it possible that such an immaterial thing that from a science perspective are only vibrations in the air, how really impacts ourselves in such a deep manner? What a huge mystery. And many people thought about the mystery, right, of music. So we do have this vision that was a very popular vision because it was presented by Steven Pinker, a philosopher, and he offers loads of examples dealing with music. And he says that music is the junk food of the brain. Well, it's quite a particular and peculiar vision. What's the argument behind that? No, we don't agree, for sure. I do not agree with that. But it's one of the theories or one of the interpretations of this ability, this passion that really impacts ourselves as human beings. He says that the ability to have this acoustic ability was quite a useful ability and skill to see if there were predators and also to find sources of food and to better understand the environment. Well, this ability, this skill was an evolutionary advantage. It could be possible that in a certain manner, due to natural selection and due to evolution, this skill had been compensated with pleasure mechanisms, inner pleasure mechanisms such as fatty food and sugary food. Why do we love this kind of food? Because thousands of years ago, well, we didn't have this kind of food, and to eat it, well, it was very interesting as humans. So brain developed a mechanism of compensation for people that loved that kind of food. And it really benefited our evolution. Today we have loads of food everywhere, and to eat a cheesecake, he offers this example. Steven Pinker, he says that eating a cheesecake, it's not useful today. But 200,000 years ago, it was useful. If you had a ready-made cheesecake, well, you could eat that because you never know when you will eat back again. Well, this is what Steven Pinker says. It's one of the theories and the proposals that we have to better understand. But I'd like to understand your perspective as a biologist. How do you see things, Leslea?
So I think when we listen to music that we do, so when I eat a bag of Cheetos or Doritos, I don't feel very good afterwards. But after listening to music, like, you feel good and uplifted. So I really like the hypothesis of Robin Dunbar, and he is a scientist who has proposed this idea that music is like grooming. So monkeys, chimpanzees, they groom each other to reinforce social bonds. And that when you get a big enough social group, there just isn't enough time in the day to groom everyone. And so music is a way to socially groom everyone simultaneously. And there have been studies that have shown that the regions of the brain that light up in response to grooming are exactly the same ones that light up in response to music. And so it feels much more like that social reward rather than junk food.
Much more interesting. Yeah, we can accept that.
That's so beautiful. And actually, I do feel that you know, music, there is something that is like a ritual, right? And like it connects all us, people from different countries, languages, different, you know, everything. It's like there are no boundaries when we play, no? And for example, you, Olushola, that when you play in the church, you say, right? And it's like every Sunday, you know, you go there and like, wow, no, you play these gospel songs and you go like you're capable of everything, right? It gives you like this strength. Sí, es muy bonito.
Yes, it's beautiful. Thank you very much for your counter-offer, counter-theory. Well, I'm the bad guy of the movie. I said that music is junk food. No, it's okay. Well, that's a vision that it's spread it all over. And, well, because Steven Pinker, it's very well known, and he is an influencer of these kind of topics, right? Well, we'll have a chat with him. Well, we were saying that the role of music, there has been published a very interesting survey that talk about flow. I don't know if you were aware about this flow. It's something that you can touch, you can feel. They smile each other, they respond to each other, looks. There is kind of a communication. It's something that really flows, that made us to be happy and to have fun. Well, someone discovered that this flow state, it's something physical that happens in the brain. There were several experiences with musicians like you all guys, and suddenly when you reach this level of awareness in the brain, you have quite a peculiar activity. And it also happens with the people working in a team and team sports, and people that have fun and had a conversation. And well, these other vision that music, it is something that really interacts physically with us to create this binding amongst us. It is quite an important argument. It's quite a heavy one, taking into account that binds amongst people and societies and human groups that collaborated more historically were those that had evolutionary advantages. So at the end of the day, collaboration, it is compensated more than greed.
What's your view on that?
I'm sorry, I'm 10 seconds behind. Yes, absolutely. When you share these rich experiences, there is definitely a bond. I could not help but think, as you were talking, actually about fieldwork. So I do a bit of fieldwork in Eastern African countries, and the people that you work with, it's such a bond. And it's a bond across languages too, because you are generally very remote. And I'll never forget one time when a dear colleague was very sick, and we were in the Afar, and there was, I was standing there with an Afar man, and we were both very concerned, and he grabbed my hand and held my hand. And it was, we shared maybe a dozen words in common, and yet we completely flowed with each other around not the science specifically, but the context of the science, and just humanity, like a humanity flow.
Well, we are commemorating the Evolution Day, and you mentioned before, Carola, you talked about music evolution, the evolution of music. Maybe you, as a musician, all these ideas related with evolution and natural selection, which are very old ideas, but, well, we always said that they are brilliant ideas. They are broad ideas, able to explain many things and applicable in many fields and disciplines. You talked about the evolution of music. I don't know if you, as a musician, can we apply this idea of evolution as a musician? How do you create new disciplines and new... Well, I think that the answer, it's quite a broad answer, but I can recall, but you know what happens? The evolution of music relying on habits and interest. In Europe, the evolution has come from the Gregorian choirs. There was an interval that was forbidden. It was the diabolus, the evil interval. And Bach took it and explored that interval of music and overcame this prejudice in a very creative moment. And Bach suddenly developed the new harmonies and the harmony changes that made us to produce this kind of jazz music. So there is this kind of evolution. But you know, Bach wrote music, composed music for churches and for singers, always in a church, and he was there closed. That was his job. And we do have Africa, the African evolution. They work a lot with rhythms. They are very, very difficult to understand. We as Westerners, we have problems when understanding African rhythms. And when we talk about harmony in Africa, there are some less notes than the notes that we have. And they develop more rhythm. In Europe, we have harmony. In Africa, we have rhythm. And then if we go to Asia, or Eastern Europe, Central Asia, and India, mainly India, it is a country that I love. And I played with Indian musicians. They do have the concept of time, which is like a circle, yeah, right? So to us, the pace is like an architecture. For them, they see like a mandala. The pace, it's like a mandala. It's like a chakra. And inside, they can put the different division geometrically divided, and they have the sacred geometry translated into ragas and rhythms. So it's a completely different system. There is no harmony, but there is a kind of a tension, a distension between notes and tones, and the tones are different than the ones that we have. The tones and half tones are different. So it's very interesting to me because I realized that there were several evolutions towards different places. Everything is music, but it's also very difficult amongst us to have a dialogue and to understand others people's music, to understand Indian music. It's very tough because it stems from a religion, it stems from a culture, because we had the Brahman, like yogi people, right? They were the ones that developed this deep sense of raga. They have to do with the time of the day, the rain, the weather, the emotions. So to us, music in Western countries, it's like minor, major, allegro, sad. It's different. Complexity, it's more in harmony, but there it's more emotions and more spiritual. So it's very interesting. I like to think about that. Such a different way to create music and also to build some bridges, because there are common elements amongst these languages. And this has a lot to do with migrations. The flamenco music, it's a great sample. Gypsies, they were not gypsies. Well, yes, they were gypsies coming from Rajasthan, and they bring from Rajasthan these complex rhythms, these tones, and suddenly they go to Eastern Mediterranean with the Ottoman Empire. They get some tones from the Balkans and also Arabic music, and finally they reach the Iberian Peninsula, when you can find Hebrew people, Jews, Arab people, and Christians, and this is to me flamenco, and this allowed me to get connected with India, and this has to do with evolution. Through evolution, I can get connected with past elements, like genes. They are genes of the past.
It also reminds me of the science that is interdisciplinary. So much of my research is some paleontology, some genetics, organismal biology. So it crosses, developmental biology. And I have found over the years that not all scientists are comfortable talking to me, because when you're in another discipline, you have to ask questions, and sometimes you feel like they're stupid questions, like maybe I should know this, and then you might ask a question that's really simple, and then they don't think very highly of you. So you have to be very trusting with the other people, and I have found just that not everyone can do that. Is that similar with the music? Because you said that it's sometimes hard to play together with people from a very different musical genre.
Yeah, totally. Like,
Yes, I recorded some music in India, and I had a solo. It was an improvisation with the clarinet, and there was a girl there that told me, no, I was in my solo time. I played loads of notes, now this tone, another tone, and it changed. I also played loads of free jazz. This is my background. My father plays jazz, and I'm a jazz musician. Lately, I experience other things, but I am a free spirit with music. So I do not know enough about Indian music in the context that I was playing with very important people, high status people, because classical musicians in India, they have a very high social status. And she told me, no, you cannot play so many notes, only 5 notes. And I said, whoa, I got angry with myself. Only 5 notes? Come on. Well, what a shame. A solo with only 5 notes? So difficult to me. I never did it before. And she was always a little bit awkward. Well, she felt awkward because I told her we had a dialogue, a conversation, but she told me, you need to understand where I come from. I have to understand where you come from. We finally put together, and it was so fruitful because I was able to improvise with only 5 notes. But there was a conflict behind, kind of tightness, your ego. Well, at the end of the day, you are talking about the evolution of the species in different conditions that create new species, different musics, and that could be so different they cannot be together amongst them. This is not the case. In the end, you played your solo with only 5 notes, which is great. You need to get adapted. Yeah, adaptation, very important. Well, it's only us speaking here, and we are reaching the end of the session, and we'd like to open the floor to all our dear guests. I don't know if any of you have any question, or would you like to comment on something, any contribution or comments? No questions. Are you sure? Don't be shy. There is one at the back of the room.
Leslea, I wanted to know if you know of any research on understanding how music was appeared, or how it not only evolved, but what happened in the brain of the human to be able to do music, or to need music, or to use music.
Excellent question. The earliest musical instruments in the archaeological record appear to be like flutes made of bones at about 40,000 years ago from sites along the Danube River. But there were likely musical instruments long before that just did not preserve in the fossil record, or the archaeological record. We think it's very difficult to figure out changes in the brain back in time because it's not fossilized. But the studies that have been done, the people who do this kind of research, there have been ideas that this, so for example, Robin Dunbar, he would put this back maybe at 250, 300,000 years ago. So when people started to have large cranial capacities and probably large enough social groups that something like music as a cohesive force would be really beneficial. And so that's before Homo sapiens. That's before our species. So this is something very old, and the Neanderthals may well have been doing music as well, based on what we can intuit, what we can infer. But it's hard science. It's hard to answer that with scientific evidence.
Just to comment on that with Neanderthals that you mentioned, there are very recent studies that the larynga and also the inner ear, it's very similar to ours. And they could produce and to feel the same frequencies as we do. So this could make us think that they were able to talk, speak, and also before that singing and producing any kind of sound or any kind of a communication, a pre-oral communication maybe. I don't know. I have my own theory because I really like this book, Sapiens. And well,
correct me if I'm wrong,
in the book, the most old things such as buildings and devices and the stone circles, everything related with spirituality, rather than finding villages, right? I don't know. Is that true or not? This is a theory that I read in that book.
It relates to my idea that music, because I think music is very spiritual, and they say that human being before, because we didn't have, this security and these societies, the cities, these structures was very much more spiritual. So I think that music really was like part of, that spirituality, I think.
Oh, it has to be, I'm sure.
So that's probably why it's so old, no?
I was recently, I was able to visit some of the cave paintings in northern Spain, and And when you go in, hopefully you've had the opportunity because you live so close to them, it's amazing, that it's very spiritual to walk into these caverns and imagining they did not have electricity, so they would have had a lamplight, an oil lamp probably, with shadows jumping around, and then the hands or the animals, and it was as a human, and granted I bring my modern culture with me, but I couldn't imagine that they didn't come in with music. Like I could feel something music in as part of that. Maybe one day you could do a concert there.
This would be amazing, I think, and very interesting because those paintings, and this is another topic, those paintings are very interesting. How they are placed inside the cave, and those paintings are not a result of a preconceived idea. They take advantage of the shape of the cave. And some figures, they can be seen brilliantly from one side of the cave and others from the other side of the cave. So this made me think that those paintings were something to be observed in a group of people, and that they belong to a ritual or a kind of a performance. So those are the most ancient samples of art. They have a lot in common with the most modern performance made by nowadays artists. I also visited the caves in Chauvet and Lascaux, and when I think about, I have goosebumps. Those guys getting inside hundreds of meters in a cave with the candles or lamps or just with a fire in a very subtle light, dim light, and creating all the images that were a creation of a cosmovision and an interpretation of the world. So I cannot imagine all the process without sound, without communication amongst them, sound communication. I don't know, a very primitive one, I don't know. But I cannot imagine without sound. I think that many people agree that there was something there, a kind of a ritual that really helped to create these bonds between societies, and which was one of the fundamental elements of social cohesion.
Hi ha més preguntes? Sí.
Do we have more questions? We have another question here. Well, you talked about spirituality, you talked about reasoning, and Leslea, right? You talked about reasoning and spirituality from the music side. And I know loads of scientists, I met many scientists that told me straightforward that they were not very spiritual. They did not believe in spirituality. So you broke this scheme, because I can see you that you are very spiritual, Leslea. And on the other hand, what do you think about this division or this perspective? And another thing, I think that the first need to use a musical instrument by the first humans, I think that it was the voice rather than any kind of instrument. I guess it was a voice, for music voice, rather than a flute. And to convey some sound through voice, it was also a way to show and to feel something that had loads of spirituality inside, this voice communication, singing between human beings. And something else, I'd like to think, and I'd love to think, that a science, in a certain manner, in some fields, wanted to explain and to let us know what many people felt spiritually. And a science always wanted to explain from facts in a scientific manner the process, so the beliefs that we have, that were beliefs in the past, and suddenly we realized that they were not magic, they were something that we could prove. Well, it's kind of a tricky thing. Well, I'm kind of confused, but you know, what I really wanted it is to talk about this relationship about spirituality, that it's identified in music, and I don't know if there is a spirituality in science.
I think many scientists, especially those of us who study organismal biology or evolutionary biology, I think there are quite a few that may feel, maybe are not practicing a particular religion, but may feel very spiritually connected with the world. So speaking for myself, I find tremendous peace with this idea that there was an origin of life and it just continues, and I'm part of this. I'm just this ephemeral configuration of molecules and DNA, and then when I'm done, it will disperse, and part of me will be part of something else. And it's just these little people are just moments in time. And I find that is very comforting. So I think, and I don't think I'm that unusual, although to be perfectly honest, scientists don't talk about these things. But I have heard of scientists that I do talk to that there's often this sense of being kind of comfortable with the world in this connectedness way, which is spiritual but not religious, if that makes sense. But we find a lot of discomfort. So I think as scientists, people who are drawn to science are more comfortable with questions that you can answer. And you can answer with some certainty because you have empirical data, you have measurements, you have something you can touch or you can see that you can quantify. And so we're drawn to those questions, and spirituality is just not one of those. And so I think many scientists may be very uncomfortable talking about the non-empirical side of life as a scientist because they feel like I have to be a scientist all the time, rather than having these two spheres of life.
Well, you know,
religious scientists, no?
yesterday, David Jova participated in a very interesting panel, and he was able to create compatibility with theology and physics. There are Nobel Prizes that declare that they have their own religions, they practice and they go to Mass. I had a conversation with some of them. Well, at a glance, as a first glance, it can be surprising, but at the end of the day, when you see things the way they are, it's compatible one thing with the other.
So it is. Last week, I was in Texas, in Dallas, Texas, at the Evangelical Theological Society meeting. And in the United States, the evangelical movement, part of that movement takes a very literal interpretation of the Bible. And so there is a movement that does not want evolution to be taught in schools because they see it as it's contrary to the Word of God. And it was really interesting going and speaking in comment to a book where they were the book is In Quest of the Historical Adam. And the first half of the book was a philosophical exploration, like, was Adam really a person or just a concept? And then the second half of the book was actually, when did Adam exist? And it was, and I was the scientist invited to come to respond to the scientific part. And it was fascinating, the response of the audience. They were all theologians, all evangelical theologians, and they were surprised that I said science can't answer certain things. Well, in science, maybe it's this, but we don't know for sure. And they seemed very surprised at not having to talk to a scientist who was uncertain about, or letting science not have certainty. And I'm hoping that might help bring some peace between science and religion. I love being in Spain, because in Burgos, for those of you who may have been there, there's this beautiful 800-year-old cathedral. And right across the river to the south is CNIA, the National Research Center for Human Evolution. I can sit in my office and I look at the cathedral on one side, and on the other side of me back there are the Sierra de Atapuerca, so where people have evidence of people living in Burgos for 1.3 million years. And there's just this harmony of the religion and the evolution that I think is beautiful.
I think that we can conclude with these final words because they are so pretty. It was so interesting. We could talk about many things, but time flies. And we'll finish with a music interpretation. But I'd like to thank you all for your presence in such a dreadful day, rainy day, and to thank Leslea and Carola. Thank you so much for your words and contribution, and all the musicians. Thank you so much for being today us and for playing this amazing music. And I'd also like, as we are here at the CCCB, I'd like to thank this institution that once again produce an activity that allow us to explore this crossroad between art, science, because this kind of knowledge and this kind of look in this hybrid manner, which is the most natural of all of them, that we were taught not to be like that, and we need to unlearn what we learned. This perspective is fundamental to understand nowadays complexity and the future complexity. So I do commemorate and celebrate that you create this kind of exploration seminars, conferences here. And that's all. Thank you so much. Thank you very much for your presence. Carola, what are you going to play? The final piece. We're going to play a piece that I composed. I had like a vision of water as a magical element, but also an element that really connects us because we are all made of water. And I dreamt something. I was under the water and I had a conversation with some beings, and I got the inspiration from that dream. And I developed together with some Indian musicians that they are not here today, but they will be connected through the internet. Okay, thank you so much. Thank you very much to all of you. And well, let's listen to your music. Thank you.
swim into the deep blue, calming sea, visit the underwater family, living into the crystal city. If you are sending me pure love, I'll be your beautiful crystals. You have to risk sometimes to get to the deepest of you. Thank you.
us demanaria un bis, però hem d'anar acabant.
Well, we need to put an end to that. Once again, thank you so much to all of you. Thank you very much for your participation. Thank you.